On Friday, July 3rd, 2026, a horrible severe thunderstorm ripped through Walworth County, Wisconsin in the middle of the day at the beginning of the 4th of July holiday. This included places like Geneva Lake and the city of Lake Geneva, very popular with tourists, resorts, and vacationers for the holiday weekend. Tragically, 3 children died when their boat capsized on Geneva Lake during this storm. So what I want to do as a meteorologist is break down frame by frame what happened with this storm, why was it so windy, and a question many people might be asking is why did the National Weather Service rate this as downburst winds or straight line winds and not a tornado? Now, the official report from the National Weather Service indicates there were 90 to 100 mile per hour winds. Hundreds of trees were blown down. 2 people were injured when silos that they were hiding near, they were motorcyclists, they got off the road, parked near silos, and those silos collapsed on them. So this was tragic winds here all around. And again, it was the middle part of the day on the Friday of the holiday weekend. So I'm going to break down exactly what this is here, straight line winds, how they can be so strong, and how they form frame by frame. So let's start out looking at the radar loop. Again, note the time on the lower right-hand corner of your screen here. Now, on the far left-hand side is Turtle, which is in Rock County. And there was a tornado warning. There was what we call a velocity couplet on the radar over Turtle, which prompted a tornado warning. And you see that hook at the beginning there, that little hook? That was the rotation. So this storm was essentially a supercell as it was to the west and southwest of Walworth County. Now, notice how the orientation changes here as it moves over Geneva Lake, Lake Geneva, Delavan, even into the Elkhorn area before just reaching Lyons and Burlington. Now, a couple of other notes. The red is the tornado warning. We'll get to when that was issued. That was towards the end of the Geneva Lake portion of this event. Then the yellow box there is a severe thunderstorm warning, which was issued before the storm arrived. And we're going to talk more about that as well. Again, we're going to dive into this frame by frame, but this is what it looked like, again, in the middle part of the day as it quickly rolled through the area. Now, this is the velocity. So this is showing the Doppler radar wind speeds. So in other words, we're peeling back the layer here, and the radar is estimating the winds. And a couple of things to point out. You'll notice that green at the beginning, not far from Sharon. Those are strong outflow winds coming out of the storm. Then you'll notice as it approaches Lake Geneva, it morphs, or it goes just north of Lake Geneva, and it kind of morphs a little bit, right? And then you start to see the green and the red next to each other as it heads towards Lyons and Burlington, hence the reason for the tornado warning. This actually gives us just a little bit better of a view. This is what we call storm relative velocity here. So in other words, what we're doing, it's the same product, but we're taking out the storm motion. So with the storm moving northeast, we're able to take the storm motion out to really get an idea of where this thing is spinning. All right. So as you take a look, as you still see that big green area near Sharon, then you start to see it morph a little bit, right? And you see before it hits Burlington, it's starting to spin there. And again, that's the green and the red next to each other. The closer those are together, the faster the spin. So now I want to get into frame by frame what's going on. And this is going to be some pretty deep science here, but I think that this is really important to go through frame by frame exactly what happened. So we're going to start out here at 12:05. Remember I mentioned the town of Turtle had that tornado warning. There you see the tornado warning. You see the hook right before it goes into Walworth County. All right. Now we're going to go to 12:12. Here we are 6 minutes later. There you can see still a little bit of a hook present, but now you're seeing quite a bit of hail and very heavy rain in the purple shaded area north of Sharon or northwest of Walworth. It's looking like it's morphing. a little bit here. All right. So right at about this time, you're going to notice the severe thunderstorm warning. So this was in effect prior to it hitting Lake Geneva, and really even before the crux of the storm came into Walworth County, this was in effect. But I'm pulling up the text here because you'll notice a couple of things. Number one, it says tornado possible. So that means that, yeah, there was still the potential for some rotation, even though it appeared to be shifting a little bit, but can't still rule out a tornado. Hail up to 1 inch in diameter. Honestly, that's low level. So that's really not the biggest deal. The biggest deal here was the wind, up to 70 miles per hour. And then it says observed, meaning that it's been observed on radar or it's been observed by somebody on the ground. So the damage threat indicator is considerable. All right, so there was a severe thunderstorm warning in effect for this region until 1 p.m. Now we're going to go to 12:19. Notice how this looks a lot different, right, than it did before. So there you have Williams Bay, you've got Como, Lake Geneva, at Geneva Lake is in there as well. So you see how it looks a lot messier. Let me go back. There's 12:05. There's 12:19. See the difference? You had that hook there before. Now it's just kind of a blob, right? So here's 12:05, 12:12, 12:19. Okay, see what I mean? So now it's looking a little more kind of like a blob as it's moving into and over Geneva Lake. Now here we are at 12:22, and you're noticing a couple of things. One is going to be the heavy rain and hail just north of Williams Bay, and you're noticing that it's really kind of gotten stronger, right? So look at 12:19, 12:22. So now we're seeing sort of the peak of the storm heading right over Geneva Lake right at this point, and you see a strengthening, right? Here as well, you see those colors getting darker. Now I'm going to take you to 12:26, getting even stronger, right? So now we're kind of at the crux of this storm. So let me take you back. 12:22, 12:26. So now that area is right over Como, and again, Geneva Lake, all these areas are still really getting hit hard right at this point. Now I'm going to take you to 12:29. What do you see here? Tornado warning is now just issued, just to the northeast of Lake Geneva. So this is the one that was issued for Lyons, Burlington, Boners Lake, all these areas. You'll see why here in just a moment. All right, we're going to break down the velocity. Now we go to 12:32. Lake Geneva and Geneva Lake, for example, starting to settle down. It's still raining heavily, but the worst of the storm has passed at this point. But look west of Burlington. You're almost seeing that little hook, right? Developing again, which we'll talk about. And now here we are at 12:36. Storm's getting a little mushier, but it's also kind of moving a bit farther to the northeast out of this image. Okay? And you see Lake Geneva and Geneva Lake kind of settling down there a little bit. So again, we just took this frame by frame. I'll show you the loop just so you can again see how all of this transpired. But I want to show this to you frame by frame for a couple of reasons. Because if you look, let's go back right to about, let's go back to 2. And what I'm looking at is north of Walworth. We may be seeing a little bit of a bowing signature developing right there. Do you see that? Just to the right where it says Lake Geneva and the north side of it is Como. That could be a little bit of a bowing segment, meaning strong winds are starting to come out of the front side of the storm. Or in other words, there's what's called a rear inflow jet that's getting stronger. And you're seeing that continue as it rolls right through Geneva Lake and Lake Geneva and heads towards Lyons. And then as we head towards the tornado warning time frame, that bowing segment kind of curves around a little bit. We almost call that a bookend vortice, although again, it's a little bit, I think a little different than that, but that's what is now prompting the rotation. So do you see what I mean by it's morphing? So it really changed shape a lot as it traversed through Walworth County. So what does all this mean? All right, let's start out with the velocity. And again, this is the storm relative velocity. So we're taking out the motion, forward motion of the storm. Sharon's at the bottom left of your screen. That is some very strong wind between Darien and Sharon at 12:06. And we had damage all along this path. Now here we are at 1212. You'll notice the wind is still there as it's approaching Williams Bay, but again, this looks like we're in a morphing territory here. We had gone from the rotation over the town of Turtle to what we call outflow dominant, again, meaning the winds are starting to rush outside the front of the storm, and that's likely what we're seeing here at 1212. Now here we are at 1216. And this is interesting because I believe that this is showing the strong winds coming out the front of the storm, but that we're also starting to see a transformation of this storm. Because look at this. Now we're over Como at 1219, and you can see those the green area, right? Strong outflow winds. But watch this. As we go from 1219 to 1226, look at what happens west of Lyons. Do you see the red and the green next to each other south of Spring Prairie? That is strong rotation. So let me go back. The rotation was starting to develop somewhere in the Como vicinity, Lake Como area, 1219 to 1222. So you can see that on radar. And this is why the tornado warning went up, as you see here, when it did. Because the rotation started to perk back up. In other words, it morphed again. Back from rotating when it was over Turtle, outflow dominant, meaning winds blowing straight out of the storm as it rolled through Geneva Lake, and then it started to spin again as the front of that bow started to interact with the storm and spin as it was heading towards Lyons and Burlington. And then finally, 1233, it's kind of going off the screen up to the north of Burlington, and 1236, it's continuing in that direction. So again, it's what we just showed here looks, again, in my analysis, to be supercellular rotation in southeastern Rock County. Outflow dominant over Sharon, meaning the storm is now whoosh, sending those winds straight, not rotating, out the front side of the storm. And that's the big difference between a downburst wind or straight line winds versus a tornado, which is spinning. And I've heard from a lot of folks that say, no, it had to have been a tornado. And, well, I don't believe that we can rule out on just to the northeast of Lake Geneva, there certainly could have been a tornado in there. As of the time of this recording, there was no evidence, as the Weather Service surveyed it, that there was debris that was lofted and spun. It was more straight out. But this is the real important distinction. This storm had 90 to 100 mile per hour estimated winds with it. Widespread damage. We had injuries and fatalities that we talked about. There is no difference between 90 to 100 mile per hour straight line winds in terms of the damage or impact versus an EF1 tornado with 90 to 100 mile per hour winds. And that's really important to understand. It doesn't matter if it came straight out of the storm or was spinning. It's horrific either way. And this is why higher end severe thunderstorm warnings that were in effect by the National Weather Service are so important to take just as seriously as tornado warnings. Now, this is where I'm going to dive a little more into the science. So again, just remember what we talked about here, that it went from rotation to no rotation, back to rotation northeast of Lake Geneva. Why is that? It comes back to this. It's something called a rear inflow jet. And I told you I'm getting sciencey on you, right? But this is so important because this isn't something even, we can show you the radar as we just did, right? And say, well, look, it's not spinning here, but it's spinning here. That's great. But what's the science behind it? Why? Why did it do what it did, right? And that's the answer that I'm trying to answer here for you. So, in a thunderstorm, you have what's called an updraft. That's the warm air going into the thunderstorm, effectively feeding it. Then you have a downdraft that comes out of the thunderstorm as well. The downdraft isn't adequately listed on here, but the downdraft is what comes down with the cooler air and the rain. But what happens, and what happened in this case, is we initially had the supercellular type storm over Turtle. Then as it moved in to Walworth County, it became outflow dominant. What does that mean? That means that we had what was called a cold pool or cool downdraft air developing at the bottom. That actually initiates high pressure. And then that warm air that's going up creates that warm, buoyant plume above the storm, but on the backside of it. And that's creating a low pressure. In other words, it's creating circulations. And that, in turn, is what's causing a rear inflow jet to develop. Now, we talk about jet streams all the time. We have a jet stream at 30,000 feet that guides storms across the country. We have a jet stream called a low-level jet at 5,000 feet that brings in warm, moist air from the south and southwest and can keep thunderstorms and squall lines going at 2-3 o'clock in the morning, many times in the summertime. But then we have this rear inflow jet. And that goes back to the Boeing segment that we were talking about just a few moments ago. Let me bring that back up again here, because take a look at, we'll just go right here. See that Boeing segment just west of Lake Geneva? That rear inflow jet is pushing through Williams Bay. It's a loft, okay? It's pushing through Williams Bay and causing that bulge, causing that bow echo, if you will. All right, it's bowing out, which means that is an area of extremely strong winds. So that's the area of strongest winds, effectively going right over Geneva Lake, along and just north of Geneva Lake, okay? And so that's the rear inflow jet that's happening there. So now let me take you back to this. So now we know that the rear inflow jet has formed. In fact, it formed back near Sharon, which is why the winds got so strong. But now the question becomes, wait a minute. Why is it that this thing was spinning? Now it's not. It became outflow dominant, meaning that that rear inflow jet formed. We had the bow echo develop, and we had the very strong straight line downburst winds pushing out of it. And that's what the radar, again, is supporting. However, what caught my attention as well was when we got back into the tornadic end of this. Well, why is it suddenly starting to spin again, right? And you can see there's a little vortice likely that developed west of Lyons. The science behind this is that we had this rear inflow jet. Again, we had this river of winds just above the surface that was howling, okay, into the storm. And when it got right around Geneva Lake, a portion of that rear inflow jet descended to the ground and locally enhanced the winds over Geneva Lake in particular. And really, you could say all across that area. It's not a huge area to go from Delavan Lake to Geneva Lake, right? So that entire area likely started to experience some of that descending low-level jet, the descending rear inflow jet, which would maximize those winds. But then the question becomes, why would this thing start spinning again? Well, think about this, and let me go back to the diagram. You see the cold pool, the blue? That starts surging out ahead of the storm just a little bit, and that is called a shelf cloud, which we know was visible on this day. So there was a shelf cloud that was present there, and that's a sign of the colder air, right? Well, what does that do? It's forcing the warm air up above it, right? Well, if you have the cold air coming out, you've got that big shelf cloud, right? Which is a typical sign of downdraft winds. A wall cloud is much smaller and spinning, which would be the sign of a tornado. And again, can't rule out that maybe there was a tornado in that rotational phase just northeast of Lake Geneva. However, nothing was found with the National Weather Service at the time of this video. So you have this descending rear inflow jet, and think about this. So you've got the cold air, you've got the shelf cloud, right? And then you have the warm air being pushed up above it. Well, what's happening? You're generating a horizontal rotation. So, and this started even farther back towards Sharon. So there's just this horizontal rotation going along with it, going along with the shelf cloud in tandem with it because it's all connected, right? So what happened to cause this horizontal rotation to flip into the vertical? And the answer to that is this rear inflow jet, a portion of it came down towards Geneva Lake and that area, locally enhancing those winds. That's why the damage was so much worse in places like Geneva Lake, Como, all these areas which had just horrific damage, because a part of that rear inflow jet came to the surface. And when that happened, it forced that horizontal rotation into the vertical, which then caused it to spin again, prompting the tornado warning as it was heading towards Lyons, Burlington, and into Racine County in particular. So that's the science in behind why all of this transpired the way that it did. Again, it has to do with what we would call storm scale dynamics here. So it's complicated. The radar can really help us peel the layers back with that. But again, the other interesting point that I want to make here is typically with shelf clouds, and we'll often see this in southeastern Wisconsin, where eventually that cold air outruns the storm. So the shelf cloud ends up way out ahead. You get gusty winds, and then you get the rain way in behind it because that outflow boundary, as we call it, has surged out ahead of the storm. That's going to cut off that warm inflow, cause the storm to weaken, and cause it to die. What I found interesting about this system is that cluster did not fall apart. It made its way all the way out over Lake Michigan and was continuing to spin, even out over the lake. Why is that? Well, if we go back to the rear inflow jet, that's what's powering this whole machine and this whole line of storms. So a portion of that came down to the surface, but not the whole thing. And the entire system effectively stayed in balance. And that has to do with wind shear in the atmosphere, the changing of wind direction and or wind speed with height. This storm stayed in balance, meaning that the shelf cloud and the cold pool did not outrun the storm. So everything stayed together even after it got out over Lake Michigan, which prompted severe thunderstorm and tornado warnings going all the way out over the lake. So that is the science behind this. And again, just to do a quick recap, rotation over turtle, outflow dominant, straight line winds, Sharon through Lake Geneva, rotation again on radar from Lyons into Racine County. So that was the entire layout. Now, again, I mentioned, I've heard from a lot of folks saying it had to have been a tornado. And at least by this video, by all accounts, it could have been in some areas. I don't believe from Geneva Lake west to Sharon that there was a tornado there. And again, that might ruffle some feathers, but it doesn't make a difference if it's coming straight out of the storm or if it's spinning. So that's the point that I want to make with that. The other point that I want to make, and this will be for a different video, is I think this is going to be the bigger point because we are all devastated about what happened. The loss of life is what obviously has all of us heartbroken. I can tell you personally as a meteorologist, having worked in Tornado Alley, having worked in so many of these places, what I do, I mean, I'll be honest with you, it's 1:30 in the morning when I'm recording this. Worked all day, came back home and wanted to cut this video. The reason why is because it's a passion, and I can speak for so many meteorologists. It's a passion to keep people safe. It's a passion to keep people informed. And when something like this happens, we know what it does to communities. I can't imagine what this family or these families are going through right now, but we are all hurting. And I know in the weather community, we are hurting, and we don't want to make this about ourselves, but we are hurting because we feel as though it is our job to keep people safe. And It's devastating. It's absolutely devastating. And we never, ever, ever want to see this happen. We never want to see this happen again. And that's going to lead, I think, to another video or maybe a series of videos of what can we do to try to prevent this from happening. Sometimes these storms, they happen really fast. There's nothing you can do. We don't know these specific circumstances that led to these fatalities at this point, at least at the time of this video. But I think what we can do going forward is learn from this tragedy, learn that it was the holiday weekend, so many boats on the water. What can we do? What kind of equipment, maybe weather type equipment, could we recommend, which I already have a lot of ideas about? So I know we are all hurting from this. I hope that the science can at least maybe bring some answers as to why it formed. And I think that's why I wanted to make this video, is because I feel like it's sort of the only way that I can help right now. But again, I know that everybody is hurting, everybody is in shock over what has happened, and it is an absolute tragedy, and it is something that, you know, will stick with all of us forever, and we never ever want this to happen again. And I hope, and we've heard about all of the communities coming together, and that's what is so great about our area, is that everybody comes together. And hopefully in future videos, you know, I'll try to make, you know, more specific videos to boating and lightning detection. And there may be some ways that we can try to mitigate this and prevent it from happening again. So if you stuck around this far to the video, I just want to say thank you very much, because this has been a really long one, but it's something that was so important to me to do for our community, to explain the science of what happened on July the 3rd, 2026.